Hello everyone and welcome back to another video. Now this is a remake of the latest video where I'm gonna do exactly the same thing. The reason why I'm doing this is because I noticed some things that I don't like about the latest video, and there's also some, you could call them mistakes, or also like I just left out some useful information. So I'm remaking the entire thing, which then hopefully will be better. So, what this video is about is this graphics card, more or less. It is generally supposed to be a sorta guide what to do when you get a graphics card in that you don't know, like when you get a broken, dead, damaged graphics card and you don't exactly know what the issue is, you just know that something's wrong with it. Because what you shouldn't do is just turn it on. There are a lot of cases where turning it on could not just yield no results, it could also actually just make it worse. Depending on, let's say, how fast your power supplies or current protection is. So yeah, and I think not a lot of people are aware of that. Like, I would think most people would just get a card and put it in, and if it blows up, then it blows up and they're sad. And I want to prevent that from happening. So, what I'm gonna use as an example here is this HD7970 Lightning, and then also a GTX 580. Both of these cards at the time of making the first video were not working. This one actually hadn't shown up at that time, but this one wasn't working. Currently both of these are working. I managed to repair them because I kinda knew what the issue was going into it. I only buy dead cards when I see a specific issue that I know I can fix. Because specific symptoms mean specific, like, indicate specific defects. But let's say you just know that there's something wrong with the card, and you don't exactly know what. You just know it's like broken. What will you do? Now, when the card shows up, the very first thing you're gonna do is just take it apart, because we will visually inspect the card. Don't worry about this bit. There was a capacitor bank here which MSI puts on some of their older Lightning cards. I removed that because it's kinda bulgy and makes the card not sit nicely on the table. It's literally just like, yeah, it's only on Lightning cards and it's pretty easy to remove. Don't really have to worry about it. So, we're just gonna remove the heatsink and also the base plate on this card. And yeah, so step one is just like take everything off the PCB that you can. Preferably while being careful. Sometimes cards, specifically GTX 400 and 500 cards, have thermal pads that get destroyed very easily, and their age, because they're now coming up on 10 years and older, doesn't really help with that. This graphics card also has some, like, these same type of thermal pads, but on this card they seem to be in better condition, though I would still be careful whenever you take something off that has thermal pads. Don't like rip it off. But yeah, step one is just remove everything. So that's the base plate off, no thermal pads there. There's a little wire here that we can remove when the heatsink is off. Let's take the little spacers. Oh, these are actually glued on. Okay, we have removed the main heatsink screws. So that should just come off like that. Now we just remove our fans and our little GPU reactor wire, which is there. And now the screws from the back were also the ones in the base plate, but there's still these two here. So always look for certain screws that you might have missed. Specifically ones around here, and they're open, like GTX 480, 580 reference cards do that. MSI likes to do it with their cards. Yeah, just when something doesn't want to come off, just look a second time for any screws that you might have missed. So now we're just gonna remove the base plate carefully and slowly. And you can see like this thermal pad right here is kind of torn. This one has a bit of a... It's also a bit damaged. This one is missing a little piece. Like, be careful with thermal pads. But yeah. Now everything is off the card. We can't really remove anything more. So this is step 1 done. Or more like the first part of step 1 done. Because what we're gonna do now is just look very closely at the PCB. If we can see any damaged parts. Like if you can see any burnt components, any components missing, any things looking kinda damaged. Now I know this card is good, because I know now it works. The issue that this card had was BGA damage, which you can't see. But always inspect the PCB closely, like look at the VRMs. There may be a blown up MOSFET. There may be some scorch mark somewhere else in like a power plane or something. If something is shorted, usually it creates visual damage, unless the power supply that this was used on has a very, very fast overcurrent protection. Then it might turn off before anything gets hot enough to create a fire or scorch something. But it doesn't always have to be a scorch mark. There can also be things like missing multi-layer ceramic capacitors, like these little ones. Also, like there's even smaller ones on the PCI Express slot right here. One of these missing can already cause the card to not work properly or to artifact. And sometimes there's also a damaged memory trace, like the little traces that go from the core to the memory chips. Sometimes these are damaged. Sometimes cards don't have these rubber standoffs that this card has, and when you screw in a screw, you can see these traces go really, really close to that screw hole. Sometimes the trace gets damaged by doing that. So pay close attention to the PCB. Like, take your time, don't rush it. And yeah, look for any visual clues for damage. Now on this specific card there are none, because the damage was non-visual. But if you can already see something, then you pretty much already know what the problem is. Which is like if it's a burned component, you would like see, oh, that's probably a short. You would try to remove that component and replace it with a new one, and then check if it works. But don't just plug it in when you do that. Like, you're gonna still want to do a check with your multimeter, which is step 2. Now, even if you find some visual damage, it is still useful to do a why did I set this to voltage? Resistance. It is still useful to do a resistance check on the graphics card. Because that's how you detect shorts. Like, if you see a burnt component, that's very likely the indication where the short is, but you still don't really know, like, sometimes you can't really see what component is part of what. So, you're gonna need a multimeter and you set it to resistance mode. And specifically resistance mode, do not set it into continuity mode. Continuity mode will think there are shorts where there are none, because there are parts of the graphics card that have a very, very low resistance, and your multimeter will see that as a short when there's none. So, for example, I know that the core on this card is good. So, if we measure the resistance of the core by, let's say, this casing is ground, and we take the positive end of one of the B-core capacitors, it beeps, because it thinks there's a short, but this is perfectly fine. If we go into resistance mode and measure again, we see this has 6.5 ohms. This is a fairly high resistance for a core, actually. Like this GTX 580 left here, that has like 600, 700 milliohms. And at this point I should say, I'm gonna assume you know how to, like, you know your way around the multimeter, how to measure things on the graphics card. I'm still gonna show everything. But I've already made a video about how you would use a multimeter on a graphics card PCB. That is also kind of long already, which is why I don't want to include it right in here. Yeah, so if you are a bit if you're a bit scared to use a multimeter on a card, or you just are not sure what exactly you want to do, there's that video that you can watch if you want to. So yeah. But step 2 is we check our resistances around the card. Now I specifically always start with the power planes, which is specifically the 12 volt power planes. Now this card has 3 sources of 12 volt power. There would be our PCI Express slot and our 2 PCIe power connectors. Now we have to check all of these individually because the power planes that these are connected to all carry 12 volts, but they are usually separated. Now let's just check the resistance from our PCI Express 12 volts to ground. And we see that this is, when the multimeter shows like 1 dot, it's just outside of measurement range. It's likely in the kilo ohm range, which is completely okay. Yeah, we have like 5 kilo ohms. That is completely okay. Interesting part about this card is also, this card has a fuse on the PCI Express slot. So you want to check that too if you have a fuse, because if the fuse is not like, you want to have a fuse that shows 0 ohms. If it doesn't show 0 ohms, the fuse is blown, and that means there's gonna be no power going to whatever this is connected to. Now this usually indicates that whatever's on the other side has a big short and drew so much current that the fuse blew. But if you repair whatever's broken and don't replace the fuse, it's still not gonna work. So yeah, just check the fuses right away, which we're gonna do now. And since this fuse is a known good, it should show, I said it should show nothing basically. Yeah, that's like, a multimeter never shows 0, this is like the minimum that it shows. So this fuse is good. There is power going through this fuse. Now, next part, we're gonna check our 12 volts power connectors. So let's check these ones. We have an even higher resistance. Even higher resistance. Even higher resistance. Yeah, okay, like this is gonna be, oh no, did I measure something wrong? Sometimes it's a bit hard. Okay, we have 3 point, okay, now 4, 5, like we have several kilo ohms. Even though the multimeter can't decide completely. Like that's okay. Sometimes sticking the probes into the card like this doesn't touch the metal contacts properly. So let's check the other connector. That has a really high resistance again. What you can also do is just stab the input inductors, like there's input inductors here, these are also connected to 12 volts, and then you see we have also a really high resistance here. Yeah, that's the one that read a couple kilo ohms. This one, no, it's reading. Like sometimes there's a bit of gunk or flux residue stuck on the metal contact, sometimes you have to scratch a little. Yeah, but we have several kilo ohms on our 12 volts power connectors. That's all good. Just for sanity check, we can also check the 3.3 volt power on our PCI Express slot, which I actually don't know what kind of resistance you want to have. But we clearly have more than 20 kilo ohms because it's out of range again, which is completely fine. So, now the next part, which I think is something I actually forgot to mention in the other video, which is one of the reasons why we're making it. The next part will be measuring the resistance from these 12 volt power planes to our VRM outputs. Because one of the most common faults that you have is a high side MOSFET shorting or failing closed, which means that your 12 volts power is permanently being shorted to the output of that VRM, which means technically the VRM is outputting 12 volts. Now that's gonna instantly kill everything, which is very bad. But usually your overcurrent protection is fast enough to cut power before anything bad happens. Though that's not always the case. Like my test bench has a really fast power supply that just immediately trips overcurrent protection. I had several high side MOSFETs fail. Every one of these cards lived. So mileage may vary. So this card is using International Rectifier Direct Fits, which is quite useful because these metal casings of these are conductive. They are connected to the was it the drain? Like the lows, yeah, this is gonna be like the low side MOSFET, which is the slightly bigger one. The metal casing is connected to the drain of that MOSFET, and the drain of the low side MOSFET is connected to the VRM output. So you could use that one, but because most cards do not have these direct fits, I'm just gonna use capacitors. So you can, you have these tantalum capacitors right here, and you see that where the plus is, that's the positive side, and the little multi-layer ceramics next to it. You can just assume have the same orientation. If not, you just check the other side, and if like, yeah. So, but what we're gonna do now is, like, I know for a fact that they have the same orientation. You can also just stick your probe in there. I'm just not gonna do it now because it's kind of annoying to do. So I'm just gonna use the multi-layer ceramic, and now we're going to test resistance to our 12 volts. We go again to this input inductor, and we again have a really high resistance that is not 0 ohms, so there's no short here. Let's check the other 12 volt. Again, really high resistance, so no short there. And let's just check let's just use the fuse. Again, really high resistance here. So now we know that there's none of the 12 volt sources being shorted to the V-core VRM output. Again, like different VRMs on a PCB, should be in the other video for multimeter things. Now let's give the same treatment to our memory VRM. Again, we have like a capacitor here that indicates the positive end. Actually, this might be the input filtering inductor for memory. Very high resistance. Like, this is probably connected to PCIe, is it? No, it's not. Interesting. Okay, I'm just gonna check everything then. I don't know what this inductor is connected to. So we check our 12 volts here. No short. We check our 12 volts here. Again, no short. And then we check our 12 volts here. Also no short. So the memory VRM is also fine. Now, on an AMD card, such as this, you have another VRM over here, which is VDDCI, or your memory controller power. NVIDIA cards like this 580 do not have a VDDCI VRM. You see you have your core VRM here, your memory VRM here, and it's kind of the same for the HD 7970, but then there's this one right here as well, where on the NVIDIA card there's just nothing there, because they don't have a VDDCI VRM. So if you have an AMD card, you gotta check this one too. So let's do that. We can also just stab the inductor. This is an SMD inductor, which has like a metal tab exposed. These ones are through holes. We can only measure these from the back, which, well, you could do, but I'm not doing it now. Like, there's a lot of measurement points. So I'm just gonna stab the inductor, and again check our 12 volts. No short. No short. And this one. Also no short. So now we know that our VRM outputs are not shorted to 12 volts, which is good because now none of our VRMs are going to, none of our main VRMs, there are still some smaller VRMs over here, but like they can break, of course they can break, but so far I've never heard of these having like big shorts. The only thing I've heard happening when these die is just that they don't work, like they don't power up. I've never heard of things happening like shorting 12 volts to the output or something like that. I've only heard of these small VRMs when they are broken, just not working. So yeah, but you should check these two, of course. Like, so yeah. And now the next thing will be more measurements, which will be our VRM outputs to ground, because that can be shorted as well. So now let's check our VDDCI and take a ground point. Let's take the ground pin of this. Wait, is this ground? just gonna use this again. Yeah. Okay, so the resistance of our VDDCI VRM is 46 ohms. That is okay. Now our core resistance, I've already shown that before, is, okay, now it's changed, like, sometimes it changes a bit. Now we have like, that's probably changed because we are using a different, yeah, on this measurement point it's a bit lower. So we have 6.4 ohms, that's really high. Like, if you have something like a 2080 Ti or 1080 Ti, your core resistance will probably look just like that. Because those cores have such a low resistance that it will just straight up look like a short. Which is kind of bad, because if you have a short there, there's not really a way to detect that unless you have like a milliohm meter. And like the minimum that this multimeter can display is 100 milliohms. And yeah, so be aware if you have like a big, like really like newish GPU, like 10, 20, 30 series, or I think Vega for AMD, and then everything that came after that. If you measure the core resistance, they will be really, really low. Now measure the memory. And the memory has 180 ohms. That's also completely okay. So now we know that none of our main VRM's outputs are shorted to ground. Which means, as far as short checking goes, like there's still maybe like a minor VRM that's shorted. Like there's a lot of smaller power rails on a card, but these big VRMs are the ones that can start a fire if they are shorted. The smaller ones, again, I've never heard of actually doing anything bad when they are shorted. So now our short detection is over, and now is actually the point. Like when you've inspected the PCB and you see there's no scorch marks, there's no visual damage, and you've checked all your resistances, you've checked your power planes, you've checked your power planes to VRM outputs, you've checked the VRM outputs to ground. If none of these are shorted, then you can turn the card on. And then check what happens. Like if the card is really dead, there's gonna be two things that could happen. Either the card will just not show an image, like assuming you have no shorts, like if there's a short, it just will directly turn itself off. But let's say you have checked and there's no shorts. You turn the card on, and the first possibility is it will just not show a picture. That would indicate that one of the VRMs is not working or not powering on, which could be very well be one of those minor power rails. Sometimes your power for the MOSFET gate drive is missing. There can be a lot of things that could be missing, in which case I would take a multimeter in voltage mode and check all the voltages of your VRM outputs. Like your core should be around 0.8 to 1.2 volts, depending on what specific card you have. Your memory should be, like GDDR5 is 1.6 volts, but sometimes the cards go down as far as 1.35 volts when they're idle. VDDCI I think is usually at 0.9 to 1 volt. These smaller VRMs, there's a PEX rail that's usually at 0.9 to 1 volt. And yeah, like NVIDIA cards, like I don't know if this NVIDIA card has it, but like newer NVIDIA cards have a 1.8 volts rail for their BIOS chips. GDDR6 and GDDR5X cards also have a supporting voltage for their memory, which I think is also 1.8 volts. Like if any of these do not work, the card is not gonna show a picture. Like the card needs all of these to fire up to work. Because why? If you don't need them, why would they be there? So yeah, if any of these does not work, like not power on, then the card is just not gonna show a picture. And then you would just have to check all your voltages and see if everything's there. And then the other possibility is that the card will show a picture, but it's gonna be like artifacting, distorted, or like it might show a picture fine and still until you go into Windows and activate the drivers, and then it's just gonna crash. that indicates that you have silicon damage, but usually it's like BGA damage. Which at this point I have to say, sometimes your card will also not show a picture just because you have really severe silicon damage, like the core or the memory is just completely destroyed, or like the BIOS chip could be dead or something. That would also cause the card not to show a picture, even though like all the VRAMs could technically be fine. Just take that as a side note, but I don't think I've ever heard of that really happening, so it should be a really slim chance that that's the case. But yeah, so what this card had, and the other card as well, it did power on, it did show a picture, it was just artifacting. And yeah, now we can get into how I fixed these cards, which is literally just what most people call the oven method. Which I would say, do not use an oven. You're going to cook all your capacitors on this card, on the card, which I think is actually the case for this, because this has a weird thing about it. Maybe some more when we have time left at the end of the video, which we don't. The video is already really long. So yeah. So silicon damage usually is BGA or like die to substrate connection damage, which is basically just a BGA but smaller. Now what the BGA is under your GPU chip and your memory chips there's a ball grid array of solder balls, which is what BGA stands for. And sometimes those connections can fail. That happens more frequently on, say, cards like this, which have big dies that run very hot and are also kinda old. So there's a lot of Fermi cards that have BGA damage, so you just heat gun them and they start working again, which was the case for this card and many others, and also this one. So yeah, the way how you repair this is just what most people call the oven method. The way I do it is I take a heat gun. People have been asking me about what temperature I set. My heat gun does not have a temperature setting. It just has like a 1 and 2 button, and I press the 2 button, which I think means more heat. And what I do is I take the heat gun, hold it around 5 to 10 centimeters away from the core, and just hold down, like spray hot air at the core for around 40 seconds. And then I back off a bit to around like 15 centimeters. And then I just slowly heat, like I just go in circuits around the entire core and memory area, so the memory chips get some heat as well, and like slowly the entire area is being heated. And I do that for a few minutes. And then I just let the card cool down a bit. And then I test it. And in case of this card, and a lot more cards, like my 780 Ti Windforce, my two 580 Zotacs, my point of view Zotac. Was that all of them? Well, I also have a 580 Lightning and a 560 Ti 448 Power Edition that I also heat gunned, but those still have problems. This actually also has still problems. But it's like working now, it's just working in a weird way. So yeah. I've only had this method fail once, which was for the Gainwatt GTX 580 that is now a semi-working e-power. So yeah, so far I've had quite a good track record of getting cards back to working with that. Though, like when you heat gun a card, there's that's no guarantee it's just gonna keep working forever. There's a good chance it might drop dead again in a couple weeks, couple months, maybe a year. If it works again, don't think it's like there to stay, because usually they drop dead again. Actually, one of the first ones, like my first 580 Zotac and the point of view GTX 580, both of these did drop dead again after some time, because these were the first ones I heat gunned and I didn't heat gun them for long enough. So I had to heat gun them again, and well, I swapped the Zotac 1.5, but I still have the point of view one, and this one is still working till today. But yeah. So if you see like artifacts when the card powers on, it's like very likely BGA damage. What it can also be is like a damaged memory trace, but you should have seen that in the first step when we visually inspected the PCB. Sometimes it's also just when the PCB is dirty, which in that case, just washing the card can help, like literally just washing it, like put it under water, take like a toothbrush and rub it off. You can use degreaser as well. And just like either just put it on a radiator to dry, or just use like use a hair dryer and dry it off a bit. Then it's gonna dry faster. So yeah. So that's pretty much the end of that sort of step-for-step guide that you would go through. Like you would end up with either, like it pretty much ends once you identify the issue. So it can even end in step 1 when you see, oh, there's like a burnt component, let's replace that, and then check for shorts. And then yeah, so like the furthest you're gonna get is with like one of the VRMs not working but visually being fine and resistance wise being fine. Like there could be something messed up in the control circuitry. I had that happen on the GTX 970 Armor that is now e-powered. That one had a V-Core VRM that was resistance wise, like I couldn't find anything wrong with it, but it just would shut down. So I just thought, okay, I'm just gonna remove the VRM and e-power it, and now it works. And also speaking of e-powers, it was I was told that on Amazon the EVGA e-Power 5 is on sale right now, and I was thinking, and I was like, this is outside my budget though. And then I noticed, no, I actually have some cash lying around, and if I put it together, I actually have enough to get it, and that I did. So there is an e-Power 5 coming, though it might take a month to arrive because it's being shipped from the US and I'm in Germany, so yeah, it's gonna have quite a ride. But yes, there is an e-Power 5 coming, which I kinda already know what I'm gonna use it for. I'm gonna use it either for this card or for the other reference 580, because both of these have kinda good cores, but I'm tending to the other one because the other one has better memory and also a slightly better core. And this one was like heat gunned, the other one wasn't. So yeah, I'm probably gonna use it on the other 580 reference because then I can actually go high voltage on that thing and see what the core can do. So yeah. And okay, we've gone over 30 minutes. Like the other video was over 30 as well. So yeah. I'm thinking of things that I might have forgotten. That's the problem when you make the video and wait like 4 days to upload it. You don't really have in your head anymore what you said in that video. So yeah, I think I forgot in the last video to check 12 volts to VRM outputs, which is like which is a really bad thing that can happen. I think I forgot to mention that AMD cards have VDDCI VRMs and Nvidia's do not. I forgot to mention typical resistances and voltages you want to have at certain VRMs. So I've done that here. So yeah, I can't think of anything important that I missed now. I would still encourage you to maybe look in the description or like a comment that I might have written under this video. If I forget something, I'm gonna put it there. But I don't think I did. So yeah, this is gonna be it. And yeah, thank you all for watching. Hope you enjoyed. I really hope this video is better than the other one. Like I thought the other one was fine until it was already public and I noticed like, oh, I kind of forgot a few things. So yeah, I still don't know if the other video is gonna stay up. Like I might as well I might just change the title to "This video is outdated, please watch the newer one," or something like that. So yeah, I don't want to drag this out to 40 minutes. So, this time, really, thank you all for watching, hope you enjoyed, and until next time, goodbye.